Okay, so getting really complicated here, taking the derivative of the ln of x over the square root of x plus 1. So if we use the chain rule here, because you've got this inside function here, ln acting on that inside function, can you see that when you take the derivative of that, you're going to need a quotient rule? And when you take the derivative of the denominator, you're going to need a chain rule again. And this is going to get super complicated. So hang on, let's do this. And then we'll look at an easier way. What's y prime? Well, the derivative of ln is 1 over whatever you're taking the ln of, as in x over square root x plus 1, times the derivative of the inside function, for which I need the quotient rule. Denominator squared, the root is just going to come off. Low times the derivative of the top, which is 1, minus the top, times the derivative of the bottom. Oh, I shouldn't have used mixed notation, but anyways. 1/2 x plus 1 to the minus 1/2, derivative of the inside function is just 1. Okay, 1 over. We have a reciprocal here. Flip and multiply. This gives me root x plus 1 over x. Okay, so this here just flipped. And I'm going to just be consistent with all of my notation here. My numerator, here's my denominator, x plus 1. My numerator, root x plus 1. Subtract, and I've got an x on the top, and I've got a 2 root x plus 1 on the bottom. Okay, so following that algebra, I've got x times 1/2, means I've got an x on the top, a 2 on the bottom, x plus 1 to the negative 1/2, I've got that root x plus 1 on the bottom. Okay, and now I'm going to distribute, or multiplying, this to both terms. And actually this simplifies quite easily. So root times root, I'm left with just x plus 1. Subtract root times the root on the bottom, they're going to cancel. I'm left with x over 2, all divided by x times x plus 1. And let's get rid of this last fraction here. We're just going to multiply the top and the bottom by 2. This distributes to both terms. So this gives me 2 times x plus 1, subtract x, all over 2x times x plus 1. Okay, let's do this in our head. We've got 2x minus x and plus 2 over 2x bracket x plus 1. There's our derivative. Okay, so let's just review that whole process. We have function composition. Inside the ln function, we've got a quotient. Within the quotient, we've got another function, a square root. So we took the derivative of ln, and we got 1 over whatever we were taking the ln of, times the derivative of x over root x plus 1. The low, d high, less high, d low, over denominator squared, and we squared the root, and the root came off. Algebra, this flipped. We took this and this, and we wrote them all in radical notation. Then we distributed that through, and then we got rid of our fractions collected like terms. There's an easier way if you use log laws. Because if you use log laws, then if we've got y is equal to ln of x over, and I'm going to write this in exponential notation, x plus 1 to the 1/2, then your ln laws say that if you're dividing inside the ln, you could subtract outside the ln. And if you have a power, you can bring the exponent down in front. This is ln x minus 1/2 the ln of x plus 1. And so if y is equal to ln x, subtract 1/2 ln x plus 1, what's y prime? Well, the derivative of ln x is 1 over x. Subtract, leave the constant out in front, take the derivative of this function. I get 1 over x plus 1, and I'm done. So this gave me 1 over x, subtract 1 over 2x plus 1. And can you see that if I gave these a common denominator, I'm going to end up in the exact same spot. And using log laws, so much easier. Hey, one last example. I'm just going to rush through this because the bell's about to ring. If f at x is the ln of the absolute value of x, find f prime. So this is useful because you remember that you can't take the ln of a negative number. So what happens if you have to take the ln of absolute? So absolute value function is piecewise defined. Okay, so this would be the ln of x if x is greater than 0. And this would be the ln of negative x if x were less than 0. Of course, x can't be 0 because you can't take the ln of 0. Remember, it's a vertical asymptote. Okay, so absolute value means you just use the number if it's positive and you take the negative of the number if it's negative, so that you turn it positive. Okay, so piecewise defined function has a piecewise defined derivative. What's f prime at x? Well, the derivative of ln x is 1 over x. When? If x is greater than 0. The derivative of ln negative x is 1 over negative x times the derivative of the inside function, which is negative 1, which just gives you 1 over x if x is less than 0. So if you're going to take the derivative of the absolute value, ln absolute value of x, so the derivative of ln absolute value x is still just 1 over x. So this weekend, finish all that off and get ready for your quiz. I'm assuming I've got everybody's chain rule assignment.